Hi. In this video, let's study about gradient, divergence, and curl. If you see this question, they've asked to find the divergence and curl, but they've given the question F vector in terms of del of xy cube z square. It means gradient is also involved in this question. Gradient usually operates on a scalar field and the resultant is a vector field. So when you get any answer after applying the gradient, you will get a vector field. So the gradient vector at any point points in the direction of maximum rate of increase of a scalar quantity. So maximum rate of increase in temperature, maximum rate of increase in pressure, etc. For all these things we use gradient. And the next one is divergence. This divergence operates on a vector field. And so this measures the net flow of a vector quantity out of or into an infinitesimal volume. So from this point, how much water is flowing outside? This is out of. Again, if we change the direction like this, it is like water flowing inside the sink. So this is into. For all these things, we talk about divergence and whether it's positive or negative, depending on that, we call it as a source or sink in fluid dynamics. And the next one is curl. This curl operates on a vector field and produces another vector field. So here the input is also a vector and the output also a vector. And this curl measures the infinitesimal rotation or circulation of a vector field at a given point. Now let's come to the question. So they've given F vector and the right hand side is del of x y cube z square. For ease, we will take this as phi. Let phi is equal to x y cube z square. And then we have to apply the gradient formula. So this F vector will become del phi. Since we have named that as phi, this is nothing but del phi by del x with respect to x into I plus differentiating phi with respect to y into j plus differentiating phi with respect to k, x, y, z, right? Z with respect to k. Since your function is in terms of x, y, and z, so this is the definition of gradient. And this F vector is nothing but del by del x of x, y cube, z square, I plus del by del y of x, y cube, z square, j plus del by del z of x, y cube, z square, k. Already how to differentiate partially I've given this as a separate video. Please just refer if you're not very strong in partial. And in this problem I will explain again. With respect to x means I'll differentiate only x terms. Other than x, everything is a constant. So if I differentiate x, what I will get? 1 into y cube z square I vector. Because this is just a constant. If I differentiate 6x d by dx of 6x, what I will get? 6, because 6 only the constant and x differentiation is 1. Same thing, in the place of 6 we have y cube z square. Similarly, if I differentiate with respect to y, I'll differentiate only y term and this x and z square will become a constant. So x z square and y cube differentiation is 3y square and j. And the last one is with respect to z. If I differentiate z, what are the other two terms which are constant? X and y cube. So keep x y cube as it is. Z square differentiation is 2zk. In case if there is any other term, say x y cube z square plus 3 or plus 3x. In this, with respect to x only, creates a difference because this will become 0, this will become 3 if I differentiate partially with respect to x. But if I differentiate with respect to y or z or anything, this term will become completely 0. Since the constants are in multiplication, it's coming as it is. If it's in addition, it will become 0. Hence, you got your f vector, that is y cube z square I plus 3x z square y square j plus, I mentioned the vector symbol everywhere, 2xy cube z k. So now we got the F vector. We have to find the divergence as well as curl. And your divergence of F vector is always denotes the dot product. So this is nothing but del by del x of this F vector. And one more thing, when we do this dot product, we use these formulas. I dot I is 0. Sorry, I dot I is 1. J dot j is 1. K dot k is 1. Other than this, any other combination, it will become 0. So this, how I will write del by del x of I plus del by del y of j plus del by del z of k. Better I'll write this dot your F vector. F vector is this term. We'll write all the three terms. Y cube z square I plus 3x z square y square j plus 2xy cube z k. We'll write all these. So when we do the dot product, this I will multiply with this. And I dot I is 1. Okay, so this I will write it as del by del x of this first term, y cube z square. Similarly, del by del y of, what is the j term here? This one, 3x z square y square. And j dot j is 1. That is why we are not writing ijk here. And then the last term, del by del z of, this is the del by del z term, and this one 2x y cube z. So this is the divergence part, and you remember the final answer of divergence is always a scalar and not a vector. And left hand side we have divergence of F vector is equal to, only with respect to x. Is there any x term? There is no x term, so this will become 0. Now I am differentiating only with respect to y. 3xz square is a constant and y square differentiation is 2y. And then the last term with respect to z, z differentiation is 1. 2xy cube is a constant. So this is your divergence of F vector. In addition to it, they have given divergence of F vector at 1, minus 1, 1. So we're just going to substitute these values for x as 1, y as minus 1, z as 1. So 3 2s are 6 and x is 1, z square is 1, y is minus 1. So we'll get minus 6 plus 2 into 1 into minus 1 the whole cube. So this term becomes minus 6 and minus 2, which is nothing but minus 8. And this is your divergence of F vector at the given point 1, minus 1, 1. Otherwise, if they didn't give the point at all, we'll stop here. Your divergence of F vector is 6x z square y plus 2x y cube. We'll stop with this. In case if this divergence becomes 0, we call it as solenoidal. And as I told you, since this is not equal to 0, we can conclude that it is not solenoidal, because some questions they will ask you to prove whether it's solenoidal or irrotational. The general divergence of F vector is not equal to 0, as well as at this point 1, minus 1, 1 also we got 8. So in case the general vector is non-zero, but this has become 0 means you can write it is solenoidal at the point 1, minus 1, 1. Okay. So next is curl of F vector. This is nothing but divergence means dot product. Curl means cross product. For cross product, what we will write? I, J, K. And what does this del means? Del by del x, del by del y, del by del z. And this F vector is from the divergence we got F vector, right? What is the first term? F vector y cube. Here it is. The first term y cube z square. Second term 3x z square y square. Third term 2x y cube z. These I, j, k coefficients, we are writing it here. So that is what you are seeing in the last term. Now this is also ready. Now you're going to do the determinant process, normal determinant. So what you will write? I into, keep this row and this column, because wherever I is there, that row and that column you'll keep it separately. And then you will multiply del by del y of 2x y cube z minus del by del z of 3x z square y square. Now minus j into, if you see the j row and j column, this is the j column. Leave this j column, neglect this, and this is the j row. This also you neglect. What is the leftover term? Del by del x of this 2x y cube z. This is what we have written. Minus del by del z of y cube z square. So we are taking these 4 stars. That is, I am leaving this column and the jth row same as determinant, and del by del x of this term minus del by del z of this term. Last plus k into. Now I am leaving the kth row and kth column. This is the kth column and this is the kth row. Now what is left over? Del by del x of this term. Del by del x of 3x z square y square minus del by del y of y cube z square. This is same as your normal determinant. This is just a simple cross one. Now we are going to find out the partial differentiation. So mention these vector symbols everywhere, and your curl of f vector will become I into, and if I differentiate this with respect to y, 2xz into 3y square minus, with respect to z means z square differentiation is 2z. These are all just constant. I'm just keeping it as it is. And then minus j into 2x. If I differentiate only x, it will become 1. So it will become 2y cube z. Again, with respect to z, y cube is just a constant. Z square differentiation is 2z. And the last term plus k into, if I differentiate with respect to x, x differentiation is 1, 3z square, y square, all constants, minus, with respect to y, z square is a constant, y cube differentiation is 3y square. And if you notice, this is 6 xzy square. This is also 6xzy square. These two terms will get cancelled. And this one is 2y cube z. This one is also 2y cube z. Cancel. 3z square y square. 3z square y square. Finally, your curl of f vector is equal to 0. And remember, this curl is associated with rotation. In case if this becomes 0, we call it as irrotational. Irrotational. So, in this problem, it is not solenoidal but irrotational. So, similarly, they may give you questions, and there is no point to substitute 1 comma minus 1 comma 0 because you don't find any xyz at the end to substitute. So, it is in general, it's an irrotational term. So, sometimes they may give the point, sometimes they may not give a particular point. And sometimes they may say that if it is irrotational, find the unknown value. So irrotational means as per the term determinant is 0. So here you may get some A, B and C. You have to compare and find those unknown values. So let's study about finding the unknown values and the scalar potential in the next video. Thank you.